Hey guys, this is Mr. Lowry here. You can't see me, but I'm here. Woo. Thanks for tuning in. I'm going to actually go through this first assignment with you. This is just a review, so if you are pretty confident with factoring, I would probably go ahead and just skip these videos. Make sure you take your attendance quiz so that I can give you points for that, and then you can kind of just go ahead and get started on this assignment. I wanted to start out with a review so you're not too overwhelmed, because a lot of today I just want you to pretty much worry about kind of learning new policies and procedures and getting ready for that. So we'll kind of start off with something easy, but if you still don't know how to factor very well, or if you're struggling with factoring, this is a concept that is really going to be important for you, especially in SM3. So I wanted to walk through a lot of these with you just to help anybody who's still struggling. So let's get started with this first one here. Now, this one right here, this is not a factoring problem. It says simplify each expression by using the distribution property. So we're going to distribute here. Now, the reason why we're distributing, or we're starting out with distributing, is because factoring is the opposite of distribution. So factoring is the opposite of distribution, or sometimes it's the opposite of FOIL. So we want to have a strong understanding of distribution and FOIL before we move into factoring, so that we can have a good foundation. So what we're going to start out with is we're going to take this 2x and we're just going to distribute it. So we're going to multiply it by this 5 and we're going to multiply it by this 5x. That's all that's happening here. So 2x times 5 should give us 10x. That shouldn't be too hard. And then 2x times 5x. So if we're doing 2x times 5x, the 2 times 5 will give us a 10, and the x times x will give us an x squared. Okay, so you got 10x plus 10x squared. And that's all we're doing here. All right, this is just very basic stuff, just to kind of get the wheels turning. Okay, so same thing here, right? If we have 10k and we multiply that by k, we're going to get 10k squared, and then 10k times positive 9, so this is a plus 9, 10k times 9 is going to give us a 90k. Okay. Now, if we take a second, this is the answer here, and this is the answer here. So we're done. We've done what we set out to do. We've simplified the expression. We distributed. Okay. But if you look at these two terms here, for example, you'll notice that each of these terms has a common factor in it, right? They both have a 10k in it, right? This is 9 times 10k, and this is k times 10k. So they both have that common factor, right? When we multiply that 10k through, they both now have a factor of 10k. So if we wanted to undo this, we could undistribute that 10k, which is called factoring. Okay, so undistributing a number is called factoring. So let's look at these problems down here, and we're going to do the exact opposite, right? So here we distributed, here we're going to undistribute. So what we want to do is we want to take a look at these two terms, and this is almost as if we're starting with an answer. We're starting with something that had been distributed already. So we're thinking, what did we distribute to these two terms, or what did we distribute to two terms to get to these two things? So we look for what are the common factors here. So if we look at this guy and this guy, well, they both have m's in it. This has m to the 1, right, because there's just one m, and this has m to the 3rd power. So they both have m's. Also, they both have a factor of 2 in it because they're both even. But we want to come up with the greatest common factor, right? We want to have the biggest thing that they have in common. So they both have a 2, that's true. They also both have a 3 in them, because 3 goes into 30 and 3 also goes into 12. They also both have a 4 in them, because 4 goes into 12 and 4 doesn't go into 30, sorry. But 6 does. 6 goes into both. 6 goes into 30 and it goes into 12. So the greatest common factor is they both have a factor of 6 in them. That's the biggest thing they have in common with the numbers. And then they both have an m. Okay? So 6m is the greatest common factor. This says identify the greatest common factor. Okay, so here's your greatest common factor. We could even label it GCF for greatest common factor. Okay? And then once we know that, we're going to factor or undistribute that greatest common factor out of the expression. So what that means is, originally I had 6m multiplying something, and when I got the result, it was this. So we're going backwards. So what we want to think about is 6m times what would give me that 30m squared? Well, 6 times 5 gives me 30, right? But I need a 30m to the third. So m times what gives me m to the third? Well, I need an m squared. So now if I do 6m times 5m squared, I'll get the 6 times 5, which is 30, and the m times m squared, which will give me the m to the third. Okay. Now the second piece, I'm going to make this a little bit bigger here so I have room. My second piece has to give me 12m. So again, 6m times what would give me that 12m? Well, 6 times 2 gives me 12. 6m times 2 will give me 12m. So this has got to be a 2. Okay? So that is factoring. That's factoring when we have a greatest common factor. Okay? Do they have something in common? Do the terms have something in common? Great. So undistribute that thing that they have in common, right? So let's do a couple more here. So again, here are the two terms, right, separated by the minus. We got to think, what do they have in common? Well, they both have v's in them. Okay, this has 4 v's, v to the fourth, right? V times v times v times v. This has 1 v, so they both have at least a v together. Okay, and then number-wise, they both have a 2, because 2 goes into 4 and 6. And there's nothing bigger that really goes into both, because like 4 doesn't go into 6, for example. So 2 goes into both of them. So this is our greatest common factor. That's the first step, right? Identify the greatest common factor. The next step is to just undistribute or factor out that greatest common factor from these two terms. So what that would look like, if we're undistributing, that means, okay, now we have 2v on the outside because we're going to basically like unfactor this 2v. And to figure out what goes in here, we're just going to think 2v times what would give me this term, right? We're kind of going backwards. So 2v times what gives you 4v to the fourth. Okay, well 2 times 2 gives me a 4. But I need a v to the fourth, so v times what gives me v to the fourth? We're going to need a v to the 3 here. Okay, so 2v times 2v to the third is 4v to the fourth. Okay, now I have this other term here, because if I factor out something from two terms, I'm still going to have, two terms here. So 2v times what is going to give me the negative 6v. Need some more room again. So 2v times negative 3 would give me a negative 6v. So that's what I want there. Okay. So again, that's one way that we can factor. It's factoring out the greatest common factor. Okay, we're going to do 2 more here, and then we'll stop the video, and you can practice on your own, or you can kind of let that digest until we move on to the next one. Okay. So this time we have 3 terms. That's okay. It doesn't really matter. We've got 3 terms. We want to find out what's common to each of them, or what common factor they have. Well, they all have x's. This one has 3, this one has 2, this one has 1. So this is the, we can take out an x from each of these. We can't take out any more than that because this only has 1 to take out. We can take out an x, and then what goes into all of these? Well, these are all multiples of 5. Is there anything bigger that can come out? Maybe a 10. Doesn't look like it. 25 doesn't really go into that, so we can't take out 25. So it looks like the biggest number factor that we can pull out is a 5. So that's the greatest common factor. Okay, greatest common factor is this guy. That's the first part of the problem. Okay, now that we have that, we want to actually factor that out, or in other words, undistribute that from the 3 terms. Right? So you can think of it as dividing, kind of. It's kind of like unmultiplying, right? Undistributing. It's almost like dividing. So if you think, some people do it like this: 45x to the third divided by 5x. If you want to do it that way, you'd be like, well, 45 divided by 5 is 9. And x to the third divided by x is x squared, right? So you can do it that way if you want to think of it that way. That's totally fine. But let's just double check. 5 times 9 is the 45 I wanted. Okay, check. X times x squared is the x to the third I wanted. Awesome. Okay. Again, I ran out of room here. Okay, so the next term here. Now we have, again, there's 3 terms to start out with, so there should be 3 terms in my parentheses when I'm done. So the next term, the second term, I need 5x times something that will give me negative 25x squared, right? Well, we know 5 times 5 is 25, okay, so 5 times negative 5 would give me a negative 25. And I need another x because I need to get x squared. So my next term inside the parentheses will be a negative 5x. Right, just to double check, 5 times negative 5 is the negative 25, and then x times x is x squared. Okay, so everything's good. We need one more term back here, and it's this positive 25x, right? So we got to figure out 5x times what number will give me 25x. Well, 5 times 5 is 25, so 5x times 5 will be 25x. Oh, just a 5, excuse me. 5x times just a regular 5. Okay, so we factor out the greatest common factor. So this is the second part of our answer. We should also probably go back and box these parts too. So each one of these questions has two parts to the question. What is the greatest common factor? Okay, great, factor it out. So this is undistribution. If we wanted to check, we just distribute. 5x times 9x squared is 45x to the third. 5x times negative 5x is negative 25x squared, okay? And then 5x times 5 is my positive 25x. So this is the opposite of distribution again. Okay. Now, if you haven't done anything on your own up till now, you should try this one on your own, right? So stop the video right now, pause it, whatever, and see if you can do this one on your own, because you should be able to get this pattern now. Okay, did you try it? All right, so we're going to jump back in. We're going to do this one together. Hopefully you tried this on your own. But let's take a look at what they have in common. Right? Well, they all have n's in them. This one has 2 n's, or n squared, n times n. This has n times n times n, or 3 n's multiplied. This has 4 n's all multiplied. So we can take out an n squared. That's the letter part. Right? The biggest thing that we can possibly take out in terms of the n's is an n squared. Okay, now if we look at the number parts here, it looks like 4 goes into all of those, which is cool. It also looks like 8 goes into all of those. Can we go bigger? It doesn't look like 16 goes into all of those. I think 8 is going to be the biggest thing that we can pull out, but if it's not, we can always go back later and factor something else out. Okay, so let's start with the 8 and see if that gets us where we want to go. So we're going to assume the greatest common factor is 8, and if we need to go back and change that, we will. Okay, if that is indeed the greatest common factor, then we need to factor it out. We need to undistribute the 8n squared. Okay, so we're going to have, since there's 3 terms in this expression, we're going to have 3 terms in the parentheses in here. We just got to figure out what those terms are. So 8n squared times what would give me this 40n to the 4th? Well, 8 times 5 is 40, so there's got to be a 5 up here. And then I need another n squared. So if I go 8n squared times 5n squared, I'm going to get my 40n to the 4th, which is what I want. Okay. In the next space here, we want to get, well, once we multiply, we'd want to get this guy, the negative 64n to the 3rd. So this space needs to be whatever I would multiply by this to get this guy. So 8n squared times what gives me negative 64n to the 3rd? Well, I need a negative 8, because 8 times negative 8 would give me that negative 64 that I need. And then n squared times what would give me n to the 3rd. So this needs to be an n, or an n to the 1, so that I get my n squared times n is n to the 3rd. Okay, and then for my last guy here, I need something here that will give me negative 80n squared when I multiply it by 8n squared. So I need a 10, a negative 10, because 8 times negative 10 will give me negative 80. And then in terms of the n's, I already have an n squared, so I don't need any more n's over here. If you double check and you look now, do these have any common factors, these 3 guys? Well, 5 goes into both of these, but it doesn't go into that one. These 2 guys have an n, but this one doesn't. So it kind of looks like we found the greatest common factor originally, so that's the greatest common factor. And we just need to box our answer here. Okay. So that is factoring out a greatest common factor. That's kind of a basic version of factoring, but if you need help with that, cool, here it is for you. You can walk through those problems, make sure you're doing it the right way. We're going to come back and we're going to do the next set of problems in just a second, but that's all for now.